myself, Dr. Deshmukh, working as Assistant Professor in the Department of Civil Engineering of Walchand Technology, Solapur. Our today's topic is Introduction to Open Channel Flow. Before this topic, you might have learned regarding the behavior of the fluid, the properties of the fluid, and you have done many practicals in the laboratory. Now, particularly in the open channel flow, this concept is related with the flow which is open to atmosphere and its behavior that we are going to study. And at the end of this topic, you are able to understand the detailed concept of open channel flow, its types and geometrical properties. See the figure, photographs. In the first, it is a channel, a constructed channel. Then second is canal section, and third one is a river. All these are open to atmosphere, and we can call these are all are open channel flow. But looking to this figure, we can classify it here directly that figure number 1 and figure number 2, they are artificial, they are constructed, and the figure number 3, that is river, that is not constructed, it is a natural one. Okay. Again, we will define it in a scientific way. Open channel flow which has a free surface and flows with gravity. In open channel flow, the flow is driven by channel slope rather than the pressure. Now here the word slope comes, and you all are very well aware about the different types of slopes, that is a mild, critical, steep, adverse and horizontal. Open channel flow is broadly classified into, that is natural and artificial. Just now we have seen the figures also. In the natural, river, streams, nalas, etc. And in the artificial, it is canal, small channel sections on the field, and flow through open sewers. Now also we can see in many of the cities, that is flow through open sewer is in practice. In the open channel flow, these are the important types of flows: steady, unsteady, uniform, non-uniform flow, laminar, transitional, turbulent, subcritical, critical and supercritical. Now go through these figures. What is steady flow? What is unsteady flow? What is uniform? What is non-uniform? In the first, we can observe here. We can observe it is a steady. It is a steady one. Okay, and the same it can be transferred in the second section. Here somehow it is unsteady, it is given over here, and here you can see it is a uniform one, and here the abrupt change it takes place, it is a non-uniform. Okay, here we can see a laminar, then in between it is a transitional, and it is turbulent. And all these are classified on the basis of Reynolds number. Reynolds number. What is the Reynolds number? Reynolds number, it is a ratio of inertia force to the viscous force. And Froude's number, when the gravity flow force is predominant in that. Now here in this figure you can see there is abrupt change in the height. This particular figure we can also say it is just an example of a hydraulic jump. Here we can say the supercritical flow, it is supercritical flow up to this one, it is supercritical flow, where the Froude's number V upon under root G Y, the Froude's number is more than 1. And here the hydraulic jump occurs. I will just tell you the brief introduction of hydraulic jump also. And here the subcritical flow, when the Froude's number changes, and you can say it is less than the supercritical flows Froude's number. Okay. Now hydraulic jump, that is energy loss takes place in a very small you can say region, very small region. Hydraulic jump we can say formed, and here the momentum equation we are going to take into account in spite of energy equation. And Froude's number, and from the Froude's number itself we are going to classify the jumps also, that is undular, then weak, oscillating, steady and strong jumps. And Froude's number we can calculate by V upon under root gy. Now this is a table which will help us to find out the different geometrical properties. First is rectangular section is there, then triangular section is there, trapezoidal section is there, and circular section is there. This is a simple area how we can calculate, then the top width which is given in here, and how to calculate the weighted perimeter. Particularly on the field, trapezoidal section and rectangular sections are most important sections, and almost again we are going to see what is the most economical or the best section, or you can say most efficient section also. These are the some important points that we have to study in this: how to calculate the discharge through the open channel, and following are some equations by which we can calculate the discharge. These equations gives us, particularly take the example of Cheg's formula. Here V is equal to C under root Rs, where V is velocity. Velocity we require to calculate discharge, because discharge is area into velocity. So velocity we can calculate by C is Cheg's constant, and R is very important term, that is weighted perimeter, and this is a slope. Similarly, Manning's formula is there. V is equal to 1 upon n r raised to 2 by 3 s raised to half. R is again hydraulic mean depth, which is area upon the perimeter. N is Manning's coefficient, and s is slope. Similarly, Bayesian's formula and Cutter's formula also has been used. They can calculate the C value, and this C value we are going to keep in the Cheg's formula, and we can calculate the velocity. Particularly, Manning's and formula and Cheg's formula is widely used in this calculation of the discharge. We will see the types. Okay, that is steady, unsteady, uniform, non-uniform, laminar, turbulent. We can add the transitional also, and subcritical, critical and supercritical flows. These are subcritical, critical and supercritical flows. They are totally classified on the basis of the Froude's number. Laminar, transitional and turbulent, they are classified on the basis of the Reynolds number. Prismatic and non-prismatic channels, these are also the important terms. A channel in which the cross-sectional shape, size and the bottom slope are constant throughout. All natural channels generally have varying cross-sections, because of you can say different velocities we can occur in different seasons, and consequently are non-prismatic. So prismatic is throughout the section the shape, size and the bottom slope is constant. Most of the man-made channels are prismatic channels over a long stretches. The rectangle, trapezoidal, triangle and circle are the common used shapes in the man-made channels. But then also we can see widely trapezoidal and rectangular are maximum used. Now we will see what is the concept of rigid and mobile boundary channels. Rigid channels are those in which the boundary is not deformable, and when the boundary of the channel is mobile and flow carries considerable amount of sediment through the suspension and is in contact with the bed, such channels are classified as a mobile channels. Then the important concept comes, that is gradually varied flow, rapidly varied flow. Gradually varied flow itself says that there is a gradual change in the, you can say, in the flow pattern, and in the rapidly there is an abrupt change. And the best example for the rapidly varied flow is a hydraulic jump. Laminar, transitional and turbulent flow, these are the flow classified on the basis of the Reynolds number. Okay, it is rho VL or rho VL R upon mu. Okay, that is you can see the formula for Reynolds number, and Reynolds number is less than 500, it is the flow is laminar. 500 to 2000 is transitional, and more than 2000 it is a turbulent one. Now these are some questions. Please see the questions. In open channel, specific energy is, second one is the flow characteristics of the channel does not change with the time at any point. And what is the type of, what is this type? The Reynolds number for a flow is channel is 1000. Which type of it is? The ratio of inertia force and the gravitational force is called as. And fifth one is, which geometrical parameter determine the efficiency of the channel? These are the answers. Go through it. These are some of the reference books for you. Study well and do the experiments carefully. Thank you very much.